Venus is usually introduced as a warning. Lead melting heat, crushing pressure, clouds of sulfuric acid. That warning is true for the ground. It is incomplete for the planet. About 50 kilometers above the surface, temperature and pressure move into a range that looks almost Earth-like compared with Mars. NASA engineers studying human Venus concepts noticed that contrast and built a study called HAVOC, High Altitude Venus Operational Concept. The idea is not to live on Venus. It is to float in Venus. This is Second Skies on the Quantum Files. Episode 2 asks whether a cloud layer can be a workplace, and what acid, wind, and Ascent demand before anyone calls it a city. The surface story dominates posters because hell is easy to photograph. The atmospheric story hides in trade studies because floating labs look like concept art. Second Skies stays with the trade study, not to sell tourism, but to score a Sky-Mars debates rarely mention. Venus teaches that the worst sky and the most interesting sky can be the same planet at different altitudes. At roughly 50 kilometers altitude, atmospheric pressure near 1 bar removes the worst pressure differential that haunts Mars habitats. A slow leak into dense carbon dioxide is still deadly chemically, but it is not the same explosive decompression story as a thin Martian outside. Gravity is close to Earth's. Solar power can be strong above the thicker haze. Buoyancy in a dense atmosphere means a habitat can be an aerostat, a craft that stays aloft because the surrounding air is heavier than a breathable mix inside. That is the pitch that makes Venus suddenly interesting. The catch is that polite pressure sits inside a corrosive, fast-moving, poorly sampled cloud deck. At 50 kilometers, Venus is not comfortable in the vacation sense. It is comparatively less murderous in pressure and temperature than the ground. Sulfuric acid aerosols still demand materials that do not quietly dissolve. Solar arrays must tolerate haze and corrosion. Crewed airships must manage buoyancy, center of gravity, and storm-scale winds. The temperate band is an opportunity, not a spa. Acid-resistant fabrics and coatings are not a single miracle polymer waiting on a shelf. They are a test campaign across seams, windows, solar covers, and flex joints under Venus temperatures and aerosol loads. A habitat is only as strong as the part that fails first, and on Venus, that part is often a material interface, not a headline subsystem. International partnerships may be required because Venus atmospheric missions are expensive and specialized. Shared instruments and shared aboard assets can reduce risk if governance is clear. Global circulation can carry a platform around the planet on timescales that affect communications geometry and solar availability. Meteorology becomes operations. Forecast quality becomes safety equipment. Medical planning must assume delayed Earth support and limited evacuation. Local authority rules from delayed ops thinking apply even when the delay is not Mars scale. Power systems must survive haze, acid deposition, and night-side segments depending on latitude strategy. Energy margin is life margin. Secondary storage cannot be an afterthought slide. Temperature at this altitude sits near what humans tolerate in heavy gear. Not pleasant, but not lead melting. That combination, near-Earth pressure, near-Earth gravity, survivable heat, is why Venus appears on comparative scoreboards at all. Mars cannot offer that trio without massive engineering. The Moon cannot offer it at any altitude. Titan offers pressure but invoices you in cryogenic cold and years of cruise. HAVOC sketched an evolutionary path. Robotic atmospheric probes first, then short crewed airship missions measured in weeks, not settlements measured in generations. Designs included large solar-powered airships, entry and inflation during descent, and an ascent vehicle to climb back to orbit. Those are not small asks. Human-scale aero entry at Venus, rapid inflation, acid-resistant materials, and a way home from inside an atmosphere are all unfinished unlocks. Treat HAVOC as a serious trade study, not a building permit. The study's value is that it forces the conversation away from surface hell and toward atmospheric engineering, a skill set Mars almost never trains. Entry, descent, and inflation remain central unfinished unlocks. A vehicle must survive Venus entry heating, decelerate, and deploy a large aerostat before it becomes a crater. Rapid inflation concepts from HAVOC-class studies are exactly that. Concepts needing tests. Anyone skipping that sentence turns engineering into fan fiction. Buoyancy management means continuous attention to leaks, temperature, and gas composition. A breathable mix inside a carbon dioxide ocean is an engineering choice with mass consequences. Crew training must include atmospheric ship handling skills that surface bases never teach. The Ascent vehicle mass fraction will dominate architecture trades. If Ascent is too heavy, the aerostat grows. If the aerostat grows, entry gets harder. Coupled trades are the real story under the Cloud City slogan. Human factors in a never-docking ship include noise, privacy, motion, and the psychology of living above an unlivable ground. Windows looking down into hell are either a mental health tool or a stress amplifier depending on design. Public communication should avoid implying permanent cities while missions are still weeks-class concepts. Trust is a resource. Overclaiming spends it. Robot precursors should map winds, measure acid fluxes, and validate inflation sequences before any crew is asked to trust a brochure. Skipping precursors is how programs collect memorials. Soviet and American probes touched Venus for decades, but mostly as brief surface survivors or orbiters. Long-lived atmospheric platforms are a different product class, closer to sailing ships than landers. HAVOC imagined that class at human scale. Whether funding follows is a separate question from whether the physics invites the conversation. Sulfuric acid clouds are not a costume detail. They attack materials, seals, windows, and solar surfaces. Wind shears and global circulation can move platforms across the planet. Navigation is not a road network. It is meteorology as destiny. Crews would live inside a machine that never parks. Maintenance outside becomes a chemistry problem as much as a pressure problem. If Second Skies sounds romantic about floating cities, this is the counterweight. Romance dies when your outer skin is a continuous materials experiment. Super rotation winds at cloud altitudes can exceed 100 meters per second in places. A habitat that drifts with the planet must plan comm windows, solar angles, and rendezvous with ascent vehicles that may not share your longitude. Tethered operations are not an option when the ground is unreachable. Every external repair becomes a contest between human dexterity and aerosol chemistry. Window materials face a triple threat: acid, ultraviolet, and thermal cycling as day-night bands pass. Designers cannot borrow Mars dome glazing and hope for the best. Seals at flex joints, where solar arrays track, where docking ports mate, where sample arms extend, are where missions quietly fail in simulation. Wind tunnel tests on Earth cannot fully replicate Venus aerosol chemistry. Flight heritage becomes the only honest credential. That is why short robotic campaigns precede any crewed float in credible planning documents. Lightning and convective storms in deeper cloud layers remind us that Venus weather is not gentle because pressure feels familiar. Updrafts and shear can load an aerostat structurally even when temperatures look manageable. Instrument suites must survive both corrosion and motion sickness at the platform scale. Compare to Mars dust storms. Visibility drops, but you can still stand on regolith and wait. On Venus, waiting means drifting, corroding, and replanning rendezvous, while acid tests every exposed gram of hardware. Getting into the cloud layer is hard. Leaving it may be harder in political terms because abort options look unlike a Mars ascent from solid ground. You need a vehicle that can climb out of dense atmosphere to orbit, dock, and go home. Mass, heat shielding, and staging all fight you. A floating outpost that cannot return crew becomes a morality problem disguised as exploration. Any honest Venus plan puts Ascent and Earth return on the critical path before habitat comfort slides. Venus also teaches planetary science with human-adjacent platforms. A long-lived aerostat could sample cloud chemistry, track circulation, and study climate runaway up close. Science value is not only settlement value, but it strengthens the case for investing in atmospheric skills that Mars programs underfund. Ascent from 50 kilometers is not a single burn. Dense air helps aerodynamic lift but punishes drag and heating on the way up. Staging must occur where pressure still matters, which means tanks, engines, and separation events happen inside an atmosphere that is chemically hostile to many alloys. Rendezvous with an orbiting mothership adds navigation under calm delay and cloud obscuration. Abort during ascent might mean ditching into acid haze rather than standing on regolith, a rescue concept with no Hollywood precedent. Program managers who treat Ascent as a footnote invite the same moral hazard as lunar missions without return vehicles. Second Skies keeps return on the critical path in every Venus discussion. An Ascent module stored inside or beneath an aerostat must be maintained in the same corrosive environment as the habitat, not sealed in a clean Mars garage until launch day. Propellant stability, tank insulation, and ignition reliability all face Venus-specific test matrices. A crew that cannot leave is not exploring. They are stranded with good views. Brochures that show cloud cities without Ascent vehicles are selling wallpaper, not missions. Venus trains atmospheric entry at scale, long-duration aerostat operations, acid-tolerant systems, and living without a surface to dig into. Mars trains dust, thin air, and surface ISRU. Those are different muscles. A program that only builds Mars muscles may discover too late that other skies needed other gyms. Venus also reframes radiation and pressure debates. The atmosphere itself becomes part of the shield and the structure. That does not make Venus kinder overall. It makes the kindness uneven, and engineering is the art of exploiting uneven kindness. Compare metrics clearly. Versus Mars. Better pressure and gravity feel. Worse corrosion and Ascent novelty. Different radiation story, similar need for closed-loop life support. Versus Titan. Closer to Earth in cruise time, harsher chemically in the clouds, less hydrocarbon surface wealth. Versus the Moon. Actual air to work with, far less radio quiet, much harder entry. The scoreboard should stay multi-axis. Venus cloud decks also offer a natural laboratory for super greenhouse dynamics. The same physics that turned a once wet world into an oven. Instruments on a stable aerostat could watch circulation patterns that no orbiter resolves. That science return does not require permanent cities. It requires honest labeling of mission class. When Venus wins an axis, say so. When Mars wins surface familiarity, say that too. Comparative thinking is the series method. Runaway greenhouse narratives matter for Earth as well as Venus. A floating platform that measures infrared balance and cloud microphysics contributes to climate models we use at home. That crossover value rarely appears on Mars settlement slides, but it belongs in a portfolio argument. Venus is not a replacement Mars. It is a different homework assignment for the same species, one that punishes acid instead of dust. Near term, better robotic atmospheric platforms and materials tests. Midterm, Short crewed aerostat missions if entry, inflation, and ascent mature. Speculative. Permanent cloud cities with industry and tourism. Second skies will not pretend those three layers are the same. The compelling claim is narrower and sharper. Venus is not only a cautionary tale, it is a second sky with a temperate band that deserves a fair engineering trial before we declare Mars the only adult option. Near-term work is robotic and materials heavy. Mid-term work is short crewed flights if and only if entry, inflation, habitability, and ascent mature together. Speculative cloud cities remain speculative. The compelling claim for viewers is not that Venus is easy. It is that Venus is not only a cautionary postcard, it is a second sky with a temperate slice that rewards atmospheric engineering. Funding Venus pathfinders does not cancel Mars surface work. It diversifies the skill portfolio. A civilization that can float in acid-tolerant hulls and ascend from dense air has options Mars alone cannot teach. That option value is the episode's honest takeaway. Watch for mission labels. A robotic balloon that survives 90 days is a triumph, not a suburb. A crewed week in the clouds is an expedition, not a colony. Language that blurs those lines is how Venus gets dismissed twice. Once as hell, once as hype. Label every Venus slide with its mission class and the audience will trust you when the class upgrades. Next time, we leave acid clouds for a different scarce resource. Radio silence on the lunar far side, and the fight to keep it from being ruined by our own machines.